Hi, Math 3 students. Today I picked a topic that I think will help you get one more question right on the ACT and one more in the math section. Makes a big difference. We're still planning on taking that ACT next week. We'll see what that looks like when the day arrives. But no, today we are talking about radians, and I'll need to give you a little bit of background of what radians are. If we were in class, I have a discovery activity that allows us to develop what a radian is together. However, because we aren't together, I'll have to give you more of a little lecture for a few minutes. So I want you to think of what is one way to evaluate pi. One of the most common ways is to use the circumference and the diameter of a circle. No matter how big or how small your circle is, the ratio of the circumference to the diameter is always pi. It's universal. So now I want you to think about degrees. We've been measuring angles in degrees since you guys were in grade school. Some of you who are skateboarders, snowboarders are familiar with terms like a 360, a 720, a 180. And those all reference how many circles you're spinning, right? So where does the unit of angle measurement of degrees come from? The Sumerians, about 2,400 years ago, noticed the track of the sun across the sky throughout the year. And they noticed it took about 360 days to complete. Does that sound familiar? So what about our 360-degree circle? Around 1500 BC, the Egyptians divided the days into 24 hours. And then around 300 BC, the Babylonians divided those hours into 60 minutes. And then further into 60 seconds. It was a base 60 number system. So think about it. Our 360-degree measurement of degrees for a full circle is based on an original guesstimation of how long it took the sun to track across the sky. So what sounds more practical to use? Radians that are based on pi, and you'll see a little bit more of why that is in just a minute, or degrees that are based on a guesstimation. Well, mathematicians will always tell you that radians are the way to go. Let me change screens here so I can see what I'm doing. Let's start with, if you haven't printed this out, go ahead and hit pause, grab it. It will be in today's lesson. Let me zoom out so you can see what it looks like. Radians. What is a radian? It is a measurement. Is that in focus? Of a circle based on the radius. Radians to radius is not a big jump, is it? Verbally. So let me show you a little bit of why. Draw a circle. Show me the radius. Now, if I were to pick up that radius right out of the circle and start to overlay it around the circumference, let me show you what would happen. One radius would land you about here. Two radiuses would land you about here. I'm going to draw in that diameter too. Three radiuses would put you about here. And then there is this little no man's land right here that's left over before I hit the semicircle. Now, guess how much of a radius I would need to fill in that gap? 0.1415 of it, dot, dot, dot. So I've got 1, 2, 3, 0.1415 radiuses to create a semicircle. So tell me, 3.14, does that sound familiar? Oh yeah, it's pi. So half a circle, semicircle, is pi radians. Full circle would be how much? 2 pi's, right? If it's pi to go half, it's 2 pi's to go all the way around. Now, as we do a little bit more of this in the future, we'll get comfortable visualizing what half a circle, quarter circle, third of a circle looks like. But today we're just going to go back and forth between degrees and radians. Let's see. I want you to, we're going from radians to degrees. Use pi over 180. Degrees to radians. Use 180 over pi. So let's see. In A, I have 50 degrees, and it wants me to convert it to radians. So let's see. Degrees to radians. Oh, I should have an S there. We are going to multiply by 180 over pi. Pause there because I got that backwards. So let's see. This one is 180 over pi. Chalk it up to nerves of being on the camera. This one is pi over 180. Sorry about that. Look at what I've done there. I just had them backwards. I apologize. So let's see. I want to convert 50 degrees to radians. So let's see. I'm going to multiply by pi over 180 degrees. We haven't done unit cancellation for a long time, but if I have degrees top and bottom, they cancel out. I can even cancel out those zeros right now, and I'm left with 5 pi over 18 radians. Sorry about that. 5 pi over 18 radians. Alex will want you to leave that in terms of a fraction, okay? Let's see. Over here, let's go ahead and go to D while we're on a roll. Degrees to radians. Pi over 180. Cancel your degrees. Cancel your zeros. We can continue reducing here. What goes into 8 and 18? They're both divisible by 2. 4, 9. I'm left with negative 4 pi 9ths radians. We'll talk about what negative angle measure means in a future lesson. Let's hit the 330 as well. Times pi over 180 degrees. Degrees cancel, zeros. Do 33 and 18 reduce? No. So I'm left with 33 pi over 18 radians. Okay, let's go the other direction. It looks like I will be working with E first. Use the inverse conversion ratio. So I would say 180 over pi. Now the reason I knew I had done something wrong earlier was my units wouldn't have canceled. So it's a good way to pay attention to if you know you're using the right one or not. Let's look and see if our fraction reduces at all. 3 does go into 180. How many times? I didn't mean to cancel out the degree symbol there. It goes in 60 times. And then I'm left with negative 7 times 60, which is negative 420 degrees. Awesome. Continue. Times. I need my pi's to cancel, so the pi needs to be in the bottom. To 6 go into 180? Yes. 3 times. 3 times 5 is 15 degrees. Continuing, times 180. Need the pi's to cancel, so it needs to be in the bottom. Does 4 go into 180? Yes. 45 times. So I'm left with 45 degrees. Now, I think we will save this corner of our journal page for another lesson. Work in Alex, make sure you look at the sample problems, and remember my office hours will be via Zoom next week, Monday through Friday, starting at 10 a.m. Thanks, class.